In this lesson, we're going to step into the world of integers, which are all the positive and negative whole numbers plus 0. Until now, you've mostly worked with positive numbers, which are greater than 0. But in grade 6, we introduce negative numbers, which are less than 0. Understanding these numbers is essential because they represent ideas like below 0 or less than nothing. The best way to understand integers is by using the number line. The number line organizes all these numbers for us. Right in the middle is 0, the starting point, or the origin. Everything to the right of 0 is positive, and everything to the left is negative. Notice how the numbers get larger as you move right, even on the negative side. -1 is greater than -5. Because -1 is closer to the right. You see negative numbers in the real world all the time. Think about the weather. When the temperature drops below 0, like to -5 degrees Fahrenheit, that's a negative number at work. Or, if you're talking about elevation, anything below sea level is expressed as a negative number. Scuba divers and submarines use negative numbers to describe their depth. The sign, either positive or negative, tells you the direction or type of change. A positive sign means a gain, an increase, or a move up. If you deposit $10 in the bank, that's plus 10. A negative sign means a loss, a decrease, or a move down. If you withdraw $10, that's -10. Always think of the sign as a directional signal from 0. Let's look at a simple temperature example in example 1. If the temperature dropped 15 degrees from 0 degree, we represent that change with the integer -15. The negative sign immediately tells us the temperature is 15 units below the 0 mark. It's a quick way to communicate the concept of being below freezing. Example 2 is about elevation. The Marianas Trench, a very deep part of the ocean, is 10,994 meters below sea level. Since sea level is considered 0, we represent this depth with the integer -10,994. -10,994. This number is a good reminder that negative numbers can be huge when describing things far below a reference point. In example 3, we use decimals with integers. If a student's lunch account has a negative balance of $4.50, we write that as -4.50 minus 4.50. This means the student owes money. It's a debt. The negative sign is a clear flag showing that the account is in the red. A neat concept on the number line is opposites. Opposites are two numbers that are the exact same distance from 0, but on opposite sides. For instance, +5 and -5 are opposites. They are both 5 units away from 0. When you combine any number with its opposite, you always get 0. It's important to know that negative numbers aren't just for whole numbers. Integers are the whole numbers and their opposites, but the broader group is called rational numbers. Rational numbers include negative fractions, like -½ and negative decimals, like -3.5. These all follow the same rules. They are located to the left of 0 on the number line. When you plot a negative integer, you start at 0 and move left. To plot -3, you start at 0 and move 3 steps to the left. The farther you move to the left, the smaller the number gets. It's a very visual way to see the value of an integer. Example 4 shows plotting fractions. To plot -½ we go halfway between 0 and 1. To plot -½ we go the same distance from 0, but move to the left, landing halfway between 0 and -1. They are opposites, so they are the same distance from the origin. Plotting decimals works the same way as shown in example 5. To plot -2.5, you know the number is between -2 and -3. Since the decimal is 0.5, It means the spot is exactly halfway between -2 and -3. The number line is crucial for comparing integers. Numbers increase as you move right and they decrease as you move left. This means that any number to the right on the line is always greater than any number to the left. This rule is especially helpful when comparing two negative numbers. In example 6, we compare -4 and -1. If you locate them on the number line, you'll see that -1 is to the right of -4. Therefore, -1 is greater than -4. The symbol is the greater than sign. When dealing with negatives, remember this key rule. The negative number closer to 0 is always the larger number. Comparing a positive and a negative number, as in example 7, is easy. We compare 2 and -5. Any positive number is always greater than any negative number, because all positive numbers are to the right of all negative numbers. So 2 is greater than -5. The absolute value of a number is its distance from 0. Since distance can never be negative, the absolute value is always positive or 0. We write absolute value using vertical bars like x squared. It tells you the magnitude or size of the number without worrying about its direction. In example 8, we find the absolute value of -7 and 7. The absolute value of -7, written as -7, is 7, because -7 is 7 units from 0. The absolute value of 7, written as 7, is also 7. Opposites have the same absolute value. Absolute value is used when we care about the size of a change, not the direction. If a rock climber descends 10 feet, we can represent that as -10. If they ascend 10 feet, it's +10. But the magnitude of the change, the distance they moved, is the absolute value, 10 feet, in both cases. Let's quickly review our key facts about negative numbers. They live on the left side of the number line. They represent ideas like debt or loss. They are smaller than all positive numbers. And here's the tricky part. When comparing two negative numbers, the one that is closer to 0 is the larger one. For example, -2 is much greater than -10. For your final challenge, use your number line skills to plot the numbers 1.5, -3, -3, and -1/2, -2/10. After plotting them, you should be able to order them easily from least to greatest. Finally, find the absolute value of the smallest number. If you can do all that, you've mastered the basics of integers.